Hello Bearcats. This lesson is on higher degree polynomials and the intermediate value theorem. We're going to first start with just basic information about polynomials. Polynomials have no sharp turns. They are smooth, continuous curves. The leading term of your polynomial in standard form, we look at something called the leading coefficient test. This gives us information about the end behavior of our graph. It's the first insight we have into what the graph's going to look like. So at the coefficient in front of the lead term, if it is positive, then the graph will go up on the right. If it is negative, the graph will go down on the right. So that gives you information about the right side of the graph. If the exponent or the power is even, then it will be the same as the right. If it is odd, it will be the opposite of the right. All right, let's look at some examples. We have 3 examples here, and we're going to look at some notation. In our first example, we have x cubed. So in front of the x is positive, so up on the right. The exponent itself, or the power, is odd, so opposite on left. So it will go up on the right, it will go opposite, or in this case, down on the left. Here's the notation. As y, as f of x, approaches infinity, so as f of x moves upward, so f of x approaches infinity as x approaches infinity. So as we move to the right of our graph is moving upward. On the left side, as f of x approaches negative infinity, so as the graph moves downward, x is also approaching negative infinity. And this is the notation to indicate end behavior. So make sure you understand that notation. If not, ask me in class. All right, here's another example. We have negative x to the 5th. All right, our negative is going to be down on the right. And 5 is odd, so opposite on left. So we're going to go down on the right, and we're going to go opposite on the left. The other thing we want to go back and remember is that the number of turns is it's up to 1 less than the power. Not always, but it can be up to no more than 1 less than the power. So this would have 2 turns. This 5th could have up to 4 turns, and we have 1, 2, 3, 4 turns. All right, and so how would we write this? All right, as our x values move to the right, so as, we could write it this way, x moves to infinity, f of x, our y values are moving to negative infinity. And up here, as x moves to negative infinity, so as our x values decrease, our y, or our f of x values, are increasing. All right, go Bearcats. Our last example here is x to the 4th. Again, positive in the front, so up on the right, and even, so same on the left. Same on the left. It could have up to 3 turns, and this one does 1, 2, 3. All right, and how would we write this? Well, as our x value, so as x approaches positive infinity, in this case, our f of x is approaching positive infinity. And on the left side, as our x values move toward negative infinity, so as our x values get smaller, our y values, our f of x values, are still getting larger. All right, that is end behavior and how we determine it. Let's take a look at an example. All right, we have a pre-cal equation here to higher degree polynomial. Let's take a look and first decide what the basic, what our graph's going to look like just in behavior-wise. So let's do that first. So it is a negative in the front. That means it's going to go down on the left. It's an odd exponent, so it's going to go up on the, down on the right, up on the left, opposite on the left. So our graph is going to look that, and it can have up to 2 turns. Or just so you know, we could have or no turns, or 0 turns. So they would decrease by 2. So you could have 2 or minus 2 would be 0. If it's a fifth degree, you could have 4 or 2 or 0, just so you know that. All right, next let's see, we can need to factor to find our intercepts. So we want to factor to find intercepts. All right, the first thing I want to do is I'm going to factor out the 1/2. Since they're all divisible by 2, I'm going to factor out 1/2. So I'm going to say, and I'm going to factor out the negative in the front. So I'm going to take out a negative 1/2. Oh, and look, they all have x's, so I'm GCFing. All right, now what will I have inside? Well, if I take out 1/2, I would have to have 4 here. And this is a little tricky, so pay attention to that, 4x squared. So 1/2 times 4 would give me 2. Make sure you realize that. A negative times a positive gives me the negative, and an x times an x squared gives me x cubed. Pay really close attention to this part. Pause and think about this. This is a really common thing that is used. This isn't calculus-driven algebra technique, but it is still algebra. All right, and then I'm going to say minus, since I want negative times negative give me the positive, and I would need 12x, because half of 12 would give me my 6. And then I took out the half, so now I just have a, and it would be a positive this time, 9, and I've already got the x. So positive times negative gives me my negative, and 9 times 1/2 would be the 9/2. That makes my factoring of this, oh, I can't, not writing very well, sorry about that. My factoring easier. Okay, so this makes my factoring here easier. Now this is a factor, and you already know that this factor set equal to 0 would have to be 0. So there's one of our zeros right now. In a minute we're going to go ahead and graph our function, which we already know has to go down on the right and up on the left. All right, now let's see if we can go ahead and factor out. We're going to use our slip and divide method because we have a coefficient. So I'm going to take that 4, I'm going to slip it over here and say times 4, and that would give me x squared minus 12x plus 36. Don't forget, in a minute I'll have to go down here and divide by 4. Sometimes we can forget that. So go ahead and factor. I'll have x and x. I'm going to multiply to 36, but add to negative 12. Ooh, I believe that will be a negative 6 and a negative 6. So 6 times negative is positive 36. That would be negative 12. But we must divide by 4, must divide by 4. So we would have x minus, and I'm going to simplify that to 3/2, and x minus 3/2. So both are the same 0 at positive 3/2. Now, hopefully you can remember this with a multiplicity of 2. If we have an even multiplicity, our graph bounces at that point. If we have an odd multiplicity, it crosses at that point. So our zeros, our x-intercepts, are 0 and 3/2 with a multiplicity of 2. Remember, it was a cubic to begin with, and so we would have to have 3 zeros. This one's twice, and then 0 is 1, so that's our 3 zeros. So let's go ahead and sketch our graph. So if this is 1 and this is 2, 3/2 is between there somewhere, so we'll put a point. Now if we bounce, Ms. Zorn always puts an X, so I don't want to cross through that. And then we know we have one at 0. So just a quick sketch, we would come down and we would bounce, and then we're going to have to go back down, and we're going to have to, cross through that 0. I didn't do a very good job of crossing through that 0, but you get the picture. All right, let's look at the intermediate value theorem. Pause and make sure you understand this. There's a lot of information in this problem. The intermediate value theorem is a process that can help you locate the intervals between two integers where the zeros occur of a function. So sometimes we don't have nice pretty zeros. We're going to have quadratics, or we're going to have decimals, or not nice integers. They're going to be between two integers. Sometimes it's not so important that we know the exact value of the 0, but we know where it crosses the x-axis. So between what integers does it make a go cross the x-axis? We're going to look at an example of how to determine this, and this will help you sketch a graph quickly if you're just sketching. So let's take a look at an example. You probably won't understand this fully yet, so we will do a lot of practice in class to help you clarify it. All right, let's take a look at this example. And we're going to kind of analyze this graph. We're going to analyze the situation before we start. The first thing we know is we look at the leading coefficient and we realize that it's positive, so we know it must go up on the right. We also know that it is an odd, so it will go down on the left. We know it can have up to 2 turns. All right, doesn't mean it crosses the x-axis twice, it just has up to 2 turns. Let's see if we can get a little information about this simply by plugging in values. And I really find this important. Remember, we use t-tables a lot in here. So if I plug in a 0, and I plug in zeros for my x's, I would have 1. And of course, this is my y-intercept, and we know that. So I would have a value at 1. So at 0, 1. Let's see, let's go to the right. So if I plug in a value of 1, 1 cubed is 1, minus 1 would be 0, plus 1 would be 1 again. So I have the value at 1, 1. Oh, so at 1, 1. So I must make a little dip there, but I don't necessarily, I don't cross the intercept x-axis because I haven't fallen down to a negative value yet. So let's go on a little bit more. Let's look at what a 2 looks like. If I plug in a 2, 2 cubed is 8. I'm just going to write the answers down here. And 2 squared is 4, so minus 4 plus 1. So that'd be 4 plus 1, that would be 5. So at 2, I'm all the way up at 5. So 1, 2, 3, 4, 5. So I'd be up here. I'm guessing my graph is going to go up and skip down here and then touch that. Now, let's see what happens on the negative side. We know that we have 1 turn already, so we need another turn. So let's try a negative 1. If I plug a negative 1 in, I would get a negative 1 minus a positive 1 plus 1. Well, these would cancel out, and it looks like I have a negative 1. So I have a value at negative 1, negative 1, negative 1, negative 1. Oh, look, somewhere between 0 and negative 1, I have to cross the axis. I have to cross the axis. All right, let's see what happens at 2. 2 cubed is negative 8. 2 squared is positive 4 plus 1. So that would be a negative 12 plus 1 would be a negative 11. So at 2, I'm way down here at negative 11. So it looks like my graph is going to go up and make another turn and come back down here. So there's my 1, 2 turns. And my interval where I have a 0, okay, this is the interval for the 0, is between, and for intervals we write them with brackets. The interval is somewhere between negative 1 and 0. I have a 0. So if I was asking for the 0, the intervals for my zeros, you could write my interval at negative 1 to 0. Somewhere between there I have a 0. All right, that's it. Tomorrow we're going to extend and we're going to give you values and have you find a polynomial, and that will be all that we do for today. All right, have a great day. Go Bearcats!